Okay, welcome back, and now let's do some examples of dealing with linear speed and angular speed. So the first example, I'm going to read it to you, says, if a car travels 1,800 feet in 24 seconds, its average linear speed is what? Okay. So this is easy because this is just dealing with the car, right? So we say that it's going 1,800 feet in 24 seconds. Okay? Again, we're going to just use the fact that distance equals rate times time, right? Because that's what the formula we use for linear speed, right? So we know that the distance is 1,800 feet, so we're just going to talk about, instead of R, we're going to talk about V for linear velocity, right? Linear speed. Okay? Usually we use R, but in this case, when we're talking about linear speed in this particular scenario, we're going to use V. Okay, but it's the same formula. So now, what are we going to do? We're going to use V equals distance divided by time. So what's the distance? 1,800 feet. What's the time? 24 seconds. And so we've got distance per unit time, so we know we got the right ratio. So we know we're dealing with a rate of change. So that's good. So if we put this in our calculator, this gives us 75 feet per second. And that's the linear speed of the vehicle. Now, what's the next example? Here, it says, if a 24-inch diameter flywheel rotates through an angle of 140 degrees in 1.1 seconds, what is the average angular speed of the flywheel? Okay, great. Well, what do we know? Well, let's draw a picture. So we've got this flywheel. Okay? And it says it goes 140, an angle of 140 degrees in 1.1 seconds. Okay? And the diameter, is that right? Diameter? Yep. The diameter of the flywheel is 24 inches, right? Is that what it says? Yeah, 24-inch diameter flywheel. Which means the radius, because that's what we need, the radius is half that, so that's going to be 12-inch. And so now, what are we going to do? Well, what's the formula for the omega, so angular momentum, or not angular momentum, angular speed. So it's omega equals 2 theta divided by what? Time. Now here's the thing. We need to use this in radians. Okay, remember the formula here uses radians. Okay, so we need to take the 140 and change it to radians. Okay, and so got to be careful there. So now, if we take the angle, so theta equals 140 times, since we're changing to radians, we want pi over 180 degrees, so the degrees cancel, and so this is what we want. So this is going to be 140 times pi over 180 divided by the time, which is 1.1 seconds. So this is going to be radians, right? over 1.1 seconds. Now, it says we want the average angular speed of the flywheel. Well, that's this. So all we have to do is plug and chug. So what do we get when we put this in our calculator? We get 2.2, or approximately 2.2 radians per second. Approximately 2.2 radians per second. Okay? Now keep in mind, we normally look at this in terms of revolutions per second, like RPMs, right? Okay? So how would we change this to RPMs? Okay? Revolutions per minute, okay? Or revolutions per second, okay? Well, what's one revolution? Well, one revolution is equal to what? 2 pi radians. So if I wanted to change this to revolutions per second, right, RPSs, then I would say 2.2 radians over seconds times what? 1 revolution over 2 pi radians. And so the radians cancel. And so I would do this, right? So I get 2.2 divided by 2 pi, and whatever that came out to be, that would be my revolutions per second. Or then you could also do revolutions per minute and things like that. Things that we, conversions that we've done before. Okay? But the answer that they wanted was radians per second, so that would be the 2.2. Okay. See you next time.